All right, so you guys are looking pretty good. All right, that's good. So you guys writing out the problem. Very nice. And then when you go to subtract, it's a lot easier if you go ahead and distribute that -1 into the parentheses first, but some people just go in and change the sign of everything, so they just write a minus in front of, the 6x squared, they write a minus in front of the 4x, and a minus in front of the 11, but again, whatever works better, or some people can just see it, you can visualize it, and you already know how to do it. Let me see, Saxon, let's see, let me see if I can help. Where are you getting, Saxon, it looks like you have 5 minus 2. I guess I'm not following that part, the 5 minus 2. Oh, because you're trying to subtract within. So you can't subtract the x cubed term from the x to the fourth term because those are not like terms. So you can't subtract those. So the only thing you can combine with the x to the fourth term is if you had another x to the fourth term. This is weird. It's not weird. It's normal. Just think of it as combining like terms. Give it a try, think if you were doing 2x plus 5 plus 1, you wouldn't combine the 2x and the 5, right? You would just combine the 5 and the 1. So really this is just an exercise in combining like terms. But the reason that I put the minus in there is because people tend to mess up the signs, but but most people are pretty good at combining like terms, they just mess up the signs. Okay, so Jasmine, keep it up. Very good. Yep, keep going. And it's good. I want you guys to do your best, like do how you would do it, because then it's easier for me to look at what you've done and troubleshoot and say, oh, wait, you just forgot this minus. And then actually you learn a lot by making mistakes like that, because then you see it and you realize you've done it, and then you tend to not do it again. So it's actually better if you give it a try. Okay, and that's fine, Emma. That's good. I'm glad you tried, and that's all I want. And Brianna, it looks like you did the vertical. Very nice. A little line in there even. Very good. All right, Saxon, that's good. Good effort. And then Miriam, just need to subtract those now. So go ahead, Miriam and Jasmine. You guys are on, or Jasmine, you started. So Miriam, go ahead and get started. Go ahead and make a guess, of how you would do it. Do the best you can. It's good to give it the old college try. And that way you won't make mistakes in the end. That's okay, Miriam. Just, yeah, you're doing good. Just work through it, and it's actually fine. I'm kind of hoping that you guys don't do it correctly, because then we can look at each other's work and we can give feedback and see what's going on. And that way, yeah, that's totally fine, Jasmine. But keep going. You guys are doing good. Just keep it up. Keep typing stuff in there. That way I can just see how are you doing. Okay, so Jasmine, Miriam, go ahead and put the next term, right? So now you're on to the cube term. What are you going to put there for that? Okay, good, Miriam. All right, Jasmine, there you go. Just put something, totally fine. Put what you think. Perfect. Nice. And then now you're on to just the x term. It just has the 1 in there, x to the first. be the linear term. So yeah, go ahead and fill out that one. Put what you guys think. Good, Jasmine, good. All right, Miriam, just put the next term. Yep, you're doing it. Keep going. Very good. Keep it up. Nice. But don't look at Jasmine necessarily because she may not be correct. You know, do what you think. Okay. Good, Emma, that's good. Okay, so let's kind of analyze what you guys have. So it looks like a lot of you guys all have 5x to the fourth, which makes sense, right? Because if you look at this term here, 5x to the fourth, and I'll underline it, there's no other x to the fourth here. So if we're going to subtract like terms, 5x to the fourth is by itself. In fact, let's do this. I'm going to color code my like terms. So I have a negative 2x to the third here and a 6x to the third there. We'll go with purple. So I've got a 3x here and a 4x here. Those are my like terms. And then the last but not least is I have a negative 8 here and a positive 11 here. So you guys are all good with the 5x to the fourth. We don't have anything to combine that with, so we could just write it. Okay, so then we move on, so we can scratch that off. We're good. So now we move on to our x cubed term. So it looks like Jasmine has a negative 8x cubed, and Emma has a negative 2x cubed. Brianna has a negative 8x cubed, and Miriam and Saxon, you erased your second term. I cannot tell. So let's think about what we have here, you guys. We have a minus 2x cubed, and then remember this minus right here. So we have a minus 2x cubed that has to distribute to every term, like that. So we have minus 2x cubed. This would be minus 4x. So minus, or sorry, not, what am I doing? Hang on. I'm not on the 4x yet. Minus 2x cubed minus 6x cubed is what we have. Why isn't it going back to pen? Okay, there we go. So we have a minus 2x cubed. And then right here we have a minus 6x cubed. Well, remember that you guys, when you have a minus and a minus, you can make this be a plus in here as long as you put your minus up there. So you got to keep that minus there. So a negative 2 plus a negative 6 does become a negative 8x cubed. So Emma, it kind of looks like probably what you did is you have a minus 6. So I think you, oh, you know what? You probably did what I was about to do is, or unless you just took this minus x cubed term here. Oh, you didn't accidentally, you tried putting 5x to the fourth into, oh, into the equation? Like with the x cubed, with the x cubes maybe? Okay. Okay. So hopefully you guys are good on these terms. So we got rid of our x cubed terms now, right? We crossed these out. So we put those together. Now we are on to our x terms. So you can see that we have two. So we have the 3x and we have the 4x. So if I combine those together, remember this minus, you guys, that we had to distribute in, right? So this is really going to be 3x, and then we have this minus, and then we have this positive 4x here. So what we're really doing is taking 3 minus 4, which is negative 1x, or just x. So if I look at what you guys have, so Jasmine added in the minus x. Brianna has that too. So Miriam, you're just missing your x term. And Saxon, left it off. And then, so yeah, Emma, it looks like you have a minus 8x. But yeah, so hopefully you understand. I'm not sure where you got that one from. Oh, you tried to subtract originally. Oh, so your like terms were not like terms, is I think what you were doing. Hi, Katie, how are you? We are just subtracting polynomials at this time. Okay, so then I'm going to cross these purple ones out, you guys. So that just leaves our last term. So we have a minus 8, and then we have a minus 11, because remember this minus, you guys. So we've got a minus 8, And then we have this minus that has to distribute to all of these, minus a positive 11. So remember that I can change this to plus and then change that to minus, and I get minus 19. So when I subtract these two polynomials, and if you guys look over here at what Brianna did, she did it vertically, and that might be easier for you guys. And she noticed how she lined up the cube terms, the x term and the constant term, and then she just subtracted down. And that might be easier for some of you guys to do it that way too, because then it's sometimes easier to see. So that definitely works. But just remember then when you're doing it, and you're going to get a lesson on it if you haven't seen the lesson already, that minus has to go and change the sign of every single term. So instead of positive 11, we now have negative 11. All right, so how do you guys feel about this? We just have one more thing to do, and then we'll be wrapped up. So any questions? So Saxon, I don't know if that helps a little bit, or Miriam, or Jasmine, but okay, so Brianna, you're in good shape then. That's good. Emma, you look good. How about Jasmine? Good. Saxon, Miriam, how about you guys? Okay, so that's good, Miriam. And Katie, you probably, can't remember if you did this one or not, but I think you might have. Or no, you didn't. But when you get to it, you will understand it. Yes, most definitely. Okay. All right, you guys, then let's do our last thing here. So our last thing is we're just going to multiply. And in some ways, these are easier, but I just want to show you how this can be different. When you guys multiply, think of it as you take every term in this first trinomial. This is a polynomial, right? But it's specifically a trinomial because there's 3 terms. But you take every single term and you multiply it by every single term of the second polynomial. So what I mean by that is I'm going to start with my x term, and I'll color code this. And again, people tend to get confused on this for some reason, but it's not that bad. So what we're going to do is take x cubed times each of these. So x cubed times x squared means we have x to the 5th. Be careful there because people will write it as x to the 6th. But what you're really doing is you have 3 x's here times 2 x's here, which gives you 5. Okay, so you add the coefficients. So I just wanted to be clear about that. So when you do x cubed times a negative 4x, you get negative 4x to the 4th, right? Because now you have 3 x's and 1, so for a total of 4. Then finally you do x cubed times 5, which gets you plus 5x cubed. Okay, so now I've done the first term. Now I have to go in and I have to do the second term, this 2x squared times each of these. 2x squared times x squared is positive 2x to the 4th. Okay, so I'm adding. 2x times negative 4x is negative 8x cubed. And then finally, 2x squared times 5 is 10x squared. So it's a little bit different, you can see, than subtracting. You don't have to worry about like terms. You just have to make sure you're good at multiplying them. Okay, so we have one more to do. We have the 10 to do. So I'm moving all this over. So the last one, the 10 right here, we're going to multiply that by everything. Oops, let's do a different color. We'll do that one in purple. So 10 times x squared is, again, plus 10x squared. 10 times negative 4x is negative 40x, and then 10 times 5 is 50. Okay, all you have to do now is combine your like terms. That's why it's good to know what like terms are, because at the very end, you have to combine all your like terms. All right, you guys, let's do that. So I'm going to look and see what I have. So I've got this x to the 5th. I don't have any other x to the 5th to combine it with. So I would just leave x to the 5th as x to the 5th, just like before. So this is a little bit of just what you were doing before, only you don't have to distribute any negatives. Okay, so now let's look at our negative 4x to the 4th term right here. We'll underline that in purple. And I've got another one here, and that's it. So I have minus 4 plus 2 is minus 2x to the 4th. So now I've combined my x to the 4th terms. Let's move on to x to the 3rd. So I've got a 5x to the 3rd and negative 8x to the 3rd. 5 minus 8 is 3, and that gives me that. Now let's go and move on to our x squared terms. I've got 10x squared plus 10x squared, which is 20x squared. And then last, oh, not exactly last, almost last, I've got this minus 40x, nothing to combine with that. That's the only x term. And then in my final number here at the very end, I have a plus 50, and I can't combine anything with that. All right, you guys. So, seems a little long. Emma's already working on it. Way to go, Emma. But all you do is you multiply first, and then do what we did last time, combine all your like terms. And sometimes it helps to kind of do it on your paper, so you can do like I did. You can underline, you can circle like terms, and then square other like terms. But if you can keep it organized in your head, what you already have, and then also organize it by highest degree all the way down to lowest degree, then it'll be easier for you not to leave anything out or not to combine the wrong things together. So try this last one, you guys. Go ahead and multiply through, combine like terms. Let's see how you do. Give it a try. So Katie, you can take 5 or 6 or 7 Notepad if you would like. Oh, I'm sorry. All right, Emma. Well, good try. Good try with the last one. But yeah, have a nice time. It is getting close to 1:30. So yeah, just watch the end, the very last one, and then fill out. And then also you actually want to watch because I'm going to talk about where you might use this too. All right. Very good, you guys. So hopefully your multiplication will go well. Okay, good, Miriam, good. I can see you're already multiplying. Awesome job. And I like how you added your exponents. That's perfect. Because people tend to get confused and they tend to multiply them instead of adding them. So that's good you remembered that. Very nice. And Brianna, just be careful. Make sure you multiply the coefficients in front of the terms as well. There you go. Perfect. Very good. And then Saxon. Saxon, you're kind of frozen over there. 6x to the third plus 4x. Oh, you're there? All right, so yeah, Saxon, go ahead and try to multiply them if you can. All right, Katie, good. So you must be student 7. Excellent, excellent. Guys, you're doing a good job. Keep it up. Doing excellent, as always. Nice, Katie. Looks good. All right, Jasmine, keep going. Just think about, look at those numbers and think about how you would multiply them. just try to walk through it. And again, don't be afraid to make a mistake. That's why we're doing it, just so that we can figure out, things that you're doing wrong so that we can point those out and that way you can think about them and then you won't do them on the actual assignment. So you'll understand exactly how to do it and you'll do it perfectly. Okay, so looks like you guys are coming along. Don't say IDK, Saxon. I saw that. You're doing good. Actually, Saxon doing really good. 36, 24. And you just have the last part, yep. Okay, and then when you guys are all done multiplying, then remember to combine your like terms. So, doing good. Keep it up. Saxon looks good. Just combine your like terms. You're in good shape. Let's see, Miriam. Looking good there too, Miriam. Actually looks pretty good. All right, Miriam, so I think you're just on to combining like terms as well. I think, Katie, you are in the process of doing that too. And then Brianna, you are, I think you're done, Brianna. Let me see. Oh, I see how you did it because you broke it apart by each one. So good. And just so you guys know, as you're doing this too, it doesn't matter if you take and switch the polynomials because remember with multiplication, it doesn't matter if you multiply, for example, 3 times 5 or 5 times 3, you're going to get the same answer. So sometimes people put the smaller polynomial in the front so it feels easier maybe because you would just take the 6x cubed times each of those 3 other ones and then you'd only have to take the 4x times each of those 3 other ones. So sometimes people switch them around just because multiplication is that way and you can do that. But you can always leave it the way it is too. Brianna, see if you take 6x to the 4th, yeah. Times x. It does. Yep, it does. I thought you might be going with that. Yeah, because the x has a 1 as the exponent. You don't see it, and so it's just a 1, but it does. Yep. That's what you thought too? Very good. All right, you guys. It looks like, Jasmine, it looks like you're close, but you're kind of still on the end. So, but it looks like Saxon, you've got a final answer maybe, and Miriam and Brianna. I know Emma had to step out. So let's look at this. It actually looks like you guys are all doing really well. So you multiplied first the 6x to the fourth, and I think everybody did this the same, times each of those. So you got 36x to the seventh, which I was really happy you guys added the exponents. Then you did it times 4x, so you got 24x to the fifth. And I think when I'm looking, what I see is that everybody did get 24x to the fifth. Although Saxon, you got to the third, I think. And I think all you just needed to do was to add the number of x's. So you have 4 next to the 6, and you have 1x next to the 4 for a total of 5. So that was the only thing. You just left it as cubed up on your top part. Okay, now we're on to the 7x. So let's multiply the negative 7x, I should say, times each of these. So we would get negative 42x to the fourth. So really important that you add how many x's you have. You have 3 here, you have 1 here, so you have a total of 4 now. And negative 42, I'm just checking. Okay, so yeah, Saxon, I think you're just struggling a little bit with just making sure to add all the x's that you have. And then let me just double check. So 42x to the fourth, good, Miriam. Brianna looks good. All right, and Jasmine. Oh, sorry, Katie, you're way up in the top, so I always miss you up there. But yep, looks good up there too. So nice job, you guys. Yeah, thanks, Miriam. See, you guys, way to go. Pick up my errors. That's awesome. So I ended up redoing that one. Okay, so nice job, you guys. Okay, you have it to the sixth, I think. You have 36x to the sixth instead of to the seventh. So something I think is off maybe there. And then 24x squared. So, oh, I just wrote it wrong. That's why. This is to the fifth. Sorry. So actually, just double checking you guys' work. X to the fifth, 40, then Miriam, 36x to the seventh. Sorry, guys, lots of detail on this one. Minus 42. Okay. Looks good, you guys. So actually looks really good. All right, you guys, so on these multiplication, just be really careful to keep track, or it's really easy to do like I did and take the 7x only times one of them and not do it times both of them. So be careful to do that. And then just be careful that you are adding your exponents and not multiplying. So any questions on that? You guys look like you did pretty good on that, actually. Any questions? Final questions? No, Brianna, okay. It makes sense. Good. Good, good, good. Jasmine, how about you? And Miriam? Katie, Saxon? It was okay. Okay. Yeah, just work on it. Definitely. Okay, good, Katie. Yeah, and Jasmine, if you work on it a little bit, it'll definitely come. And then when you guys watch the lesson too and you see it again, that always helps as well. So Saxon, how about you? You are silent up there. Oh, you still need to work on it with your cat face there. Yes, good. All right, you guys. So again, don't feel bad, but this is also why it's going to be important when you do the practices that show me your work too, because if I can see that you are doing everything right and then just one thing got mixed up, it's easy for me to see, oh, they know what they're doing and they just mixed up one little thing and it's not a huge deal because it's pretty easy, as you can see, to make errors with this. All right, you guys, so what I want to end with, and it goes along with your take it out to your discussion in Schoology, is why would we ever, let's say, add or subtract polynomials or multiply them? And if we talk about that just for a second, when you are in business, a lot of times you have, if you guys think about how you make profit, for example, profit is revenue minus expenses. And revenue can be in the form of some kind of polynomial that represents revenue. Expenses can also be in a polynomial. And if you subtract those, you end up with net profit. So that might be an example where you might subtract your polynomials. Also, if you think about geometry as far as multiplication, when you guys are finding volume, you're multiplying 3 potential polynomials to find volume, especially if you don't know the exact lengths of sides. Same thing with surface area. You're multiplying polynomials to find surface area or just area in general. So there's a lot of ways or a lot of reasons why you might add or subtract or multiply two polynomials. So what I want you guys to do for your ticket out is to think of a real life example that would cause you to add, subtract, or multiply two polynomials together. And you guys, when you think of polynomials, it doesn't have to be this long, complicated, higher order polynomial. It can be, a quadratic even, something like that. So it doesn't have to be that complicated. But when would you multiply two polynomials together? And even remember a binomial, 2x plus 10 is a type of polynomial. So think of a real life example and explain your example, and then what would you get after you perform that operation? So for example, if you were multiplying together three sides of a prism, you would end up with volume at the end. In my other example, if you took revenue minus expenses, you would end up with net profit if you subtracted those. So try to think of something that you guys could write about for the discussion. All right, that concludes our webinar, you guys. Way to hang in there. Any questions before you take your ticket out? You guys good? Okay, just raise your hand. Raise your hands, say goodbye, and then I know everything is good. So you guys use the little hand person. Oh, good. Brianna, Miriam, Saxon, Jasmine. Nice job, you guys. All right, way to go. Katie, how about you? I didn't see your hand. Oh, Miriam, you're good too. Ah, thank you, Katie. Thank you. Very good. All right, you guys, good job, and I will see you all soon, maybe tomorrow.